Hello and welcome to my channel. So let's look at today's daily challenging question. 75. Array norms with n objects colored red, white, or blue, sort them in place so that objects of the same color are adjacent with the colors in the order red, white, and blue. We will use the integers 0, 1, and 2 to represent the color red, white, and blue respectively. You must solve this problem without using sort function. So question example 1, 202110, it returns 001122. Example 2, 201 returns 012. Example 3, 0 returns 0. Example 4, 1 returns 1. So the norms is pretty only have between 1 and 300 elements. And also the follow-up, could you come up with a one-pass algorithm using only constant extra space? So um, for this question, we can use the approach of quick sort. So we can implement the quick sort, and then it will be in place. And also constant extra space. Time complexity is the worst case is the worst case is n squared, but on average is n log n. So let's draw something here. So firstly maybe talk a little about quick sort. So for the quick sort, we need to do recursion. So firstly we have the low is 0 and high is n minus 1. Then we need to call a function called partition. We also need to decide a pivot point. So in this question, in this implementation, we can use the high as a pivot point. Then we need to organize the array so that all the values smaller than pivot point is on the first half of the array, first part of the array. All the values higher than pivot is on the second part of the array. So in the end, we should have pivot in the correct location. Then what we need to do is we need to split the array further and do the same for the left split and the right split. So we are already done with the pivot, like this index. So we don't need to have assume this index is k. Then here we actually have k minus 1, and this one is k plus 1. So we continue to split and until there is only one element in each part. Then we are done with the entire process. So hopefully it's clear, and let's start implementing this. So we need to call this quick sort norms 0, norms length minus 1. So in the quick sort, we have low and high. So if the low is smaller than high, then we can call the quick sort. We actually need to get the partition. We will implement partition norms low and high. Then we call it again the recursion low p minus 1 and high like a p plus 1 to high. Yeah, then we just need to implement the partition. So we can also aside we can pick the highest index value as a pivot. Then we go from the um, low to high. Also, we need to define like left or. This should be int. We're returning an int. Left or is low. So then if this value nums I is smaller than pivot, then we need to do a swap. We can implement the swap as a separate method. So we do swap I and left wall. And also we increase left wall, incremental left wall. And in the end, we need to swap left wall with high. Yeah, and then we just return the left wall. Return the left wall as a pivot point. So the last part we need to do is to implement the swap. Yeah, so temp. And then we can assign nums j to nums I, and nums j will. Yeah, so this should have done that. Yep. Okay, so it passed, and so this is a classic quick sort, and it's I think it's very important to understand and memorize the quick sort process. So thank you for watching. If you have a question, please comment on the video. If you like it, please subscribe or click like button. Thank you very much.